Do animals cooperate? Cooperative tasks have been demonstrated in many species. Ants work together to gather food, and chimpanzees work together to compete with other groups. Less research has focused on the role of communication in cooperative tasks. In this paper, King et al. Reveal how dyads of bottlenose dolphins use vocal signals to communicate during cooperative tasks. The participants in this study consisted of 4 bottlenose dolphins, split into 2 groups or dyads. One group consisted of 2 female dolphins and the other of 2 male dolphins. In a series of trials, members of each dyad were required to swim across a lagoon and each press their own underwater button simultaneously, within a 1-second time window. If the buttons were pressed simultaneously, a success sound played, and the dolphins were positively reinforced with fish and social interaction. If buttons were not pressed simultaneously, a failure sound played and no reinforcement occurred. In phase 0, the dolphins were simultaneously released and swam to the A buttons across the lagoon. In phase 1, one dolphin was released immediately and the other was released 1 to 5 seconds later. In phase 2, the dolphins were tested with randomized delays between 0 and 5 seconds. In phase 3, the dolphins were again tested with incremental delays, but longer ones between 8 to 20 seconds. In phase 4, the dolphins were again tested with randomized delays, but these ones were longer, lasting between 1 and 20 seconds. In phases 5 through 8, the dolphins' vision of each other was restricted. This way, the dolphins could not rely on vision and had to use vocal signals to communicate. In phase 5, the dolphins were simultaneously released from 3 different locations within the lagoon. In phase 6, the dolphins were released from one of the 3 locations with randomized delays. In phase 7, the button was moved to location C rather than location B, and dolphins were released from the original location with randomized delays. In phase 8, the button was again moved, this time to location D, and the dolphins were released from the original location with randomized delays. The researchers found that the time between button presses was significantly shorter when the dolphins used whistles to communicate. In both dyads, the researchers found that significantly more whistles were produced in successful trials compared to failed trials. For both dyads, the whistles typically occurred towards the end of the trials and right before the button was pressed. Both dyads also showed that a shorter time between the last whistle produced and the first button pressed is associated with higher success. They also found that in the trials where whistles were used, more whistles led to more successful trials for males but not for females. More gender differences revealed that males produced 2 whistles per trial on average, whereas females produced only 0.37 whistles per trial. More gender differences showed that the female dyad spent significantly more time waiting for their partner and swimming together with their partner compared to the male dyad. Overall, the results of this study show that the dyads used in this trial are capable of using vocal signals to communicate during cooperative tasks. Button press intervals were significantly shorter, and the chance of success was significantly higher when the dolphins used vocal signs to communicate. There are several limitations of this study to keep in mind. Due to the small sample size of this study, we cannot generalize these results to all bottlenose dolphins. Also, even though the dyads successfully used whistles to communicate, they were also able to complete the task without vocal signs.